Hi there, and welcome back to Tripplikit, and welcome to part 4 of our series on developing PCBs using KiCad. I still haven't looked up how you pronounce it. PC development software. And in this video I am actually going to get on, lay the board out, and send it off to be made. And the video will be in sort of 2 parts, because then I will wait until I have some boards back and we can actually solder them together and try them. So without further ado, let us crack on and lay out our board. Okay, so on I think the second video when we were laying out the schematic, I was bemoaning the fact there was no way just to list the nets. However, we find in the PCB there is a way to list the nets. So here we have the nets if we need it, and we can see any net that we haven't put a name on. I stuck a label on. It's called net something, component, pad, whatever. Just makes up a name based on, I guess, where it starts. Okay, important thing to consider when putting down tracks on a PCB is how close they are together and how wide, how thick they are. If they're too close together and the board in manufacture is under etched, then you can get bridges between the tracks. And if they're too narrow and the board is slightly over etched, we can etch through the track. Now 6mm or 0.15 of a millimetre, a mil being 1/1000th of an inch, is standard for our very cheap prototyping. So as long as we're within that, and that's for spacing and track thickness. Also, our board is carrying, well, not high currents, but significant currents. So we need to have sufficiently thick tracks to carry that current. Now, we have here a board setup button, and if we hit that, we go into net classes. So a net class just defines the track width, the track clearance to the next track, and via size and via drill. We don't need any of the other stuff for various types of net class. And we define, there's a default, and currently they're all default. So we are also going to define a power one. There we go, power. And for now it's just filled in those to the default values, and we are going to set 4 nets to that if we can find them. The 2 battery power ones, that's that and that. Charge voltage and the supply voltage. Okay, back up here. Now that default value, those default values, track width of 1/4 of a millimetre, would actually carry the current we need. It's about an amp with a 10 degrees centigrade temperature rise, I think, from memory. Don't quote me on that. However, I'm going to put that up to 1.5 times, just for a bit more solid, for a bit thicker tracks, and the power I'm going to put up to 3 times that. So that's 0.75 via size 1.8 millimeters via drill 1.2 millimeters. We're not using micro wires. A D-pair width and gap. Don't know what that is. I'd have to look that up. Okay, and I am going to put this up to 1.5. I haven't put this up to... Well, I'm just going to double this. So this I am going to put up to 3, 1.5. Times a quarter is about, call it 37.37. Call that 9. And Viadrol 6. Okay, we're ready. Okay, so if I now connect these diodes up, we go into there. So that goes to there. You can see that's a nice fat track, and it even tells you what the net is on there. Okay, but if I start a track out of here, just for now, you can see that's half the width or thereabouts, and we can, of course, well, not of course, but we can change the track width if we wish to. So we could put 0.5 in there and have that bit fatter. Okay, so what I am going to do now is try and crack on and get the components down and most of the tracks in, and then we'll come back and reevaluate. Okay, as you can see, got most of the tracks in actually quite quickly. Makes a fair amount of difference when you don't have a 100-pin microcontroller to plumb in. And as you can see, there are some tracks, some connections which are not yet added, and they are grounds, and we will come to them later. Firstly, I'd just like to show you something. So here's a schematic. If I update PCB from schematic, there, it's given me 2 errors because the pin headers are 5-pin footprints and on the schematic the 6 pins, so it finds those. That's good. So yes, grounds. Now I am following best practice here in using the bottom surface as a ground plane. If we connected it up just like that, with those tracks would just be like wires flopping about and would be prone to picking up EMC and indeed transmitting it. So what we do is we put a ground plane on the bottom, and any electromagnetic radiation that arrives at the printed circuit board is just dissipated in the ground plane. Not probably necessary on a board like this with a relay and a couple of transistors on, but as I say, it's best practice, so we're gonna do it anyway. So we need to place, that is a copper ball, and we're going to place it on the bottom copper, and we are going to okay, that's good, and so it's asking what we want to connect the copper port to, and we want to connect it to ground. And there's lots of other stuff, thermal reliefs. We're doing it in the standard way for this. So we're going to, before I send the board off, I need to check with the manufacturer what sort of clearance they need between anything copper and the edge of the board. There we go. So that's connected up all my grounds. Now if I... there we go. And there are one or two other connections to go, but you can see these are grounds and there are just the thermal relief. That's so you can solder onto it. If it just was part of the ground plane, when you tried to solder it, all the heat would go off into the ground plane and you'd never get to solder it. Good. So what now? I have some connections to do. I need to check that these two connectors for the USB and the SD card are pointing the right direction, so the USB board isn't over the main board. I need to check the heatsink because that rectangle was just something I put in roughly for now, and there need to be two holes for screws to hold the heatsink down. And apart from that, I think we're nearly there. And I sort of fed some board dimensions into the PCBWay's website, and if your board is greater on either dimension than 100mm, the price goes up alright from $5 to $20, which is not the end of the world, but we might as well keep it as cheap as possible. So I have extended the board. I've squared the board off because there's no reason why it should be the same shape as the Arduino board, and I've extended it top and bottom as we look at it, and the top there, so I can get the LEDs on the top here. As I say, the two I don't know, daughter boards you'd call them, I suppose, and I've stuck some resistors down here. So as you can see, I do have one or two more wires to put in and the heatsink, and then we can get on to checking it, and I'll bring you back for that. Okay, so I've basically finished it now, and I did add a couple of capacitors, just 100 nanofarads, on the voltage sense lines, just to smooth them out, just in case. A couple of capacitors on the supplies in case any nasties get on the wires, and a couple of grounded pads to mount the heatsink to. So if we go to the PCB, so here it all is, and I've added some labeling on the terminal block here, and on the LEDs, and shuffled a few things about and relayed it out. Oh, and I've left 1mm round the edge with nothing on it. It doesn't actually say on the website if you should or should not leave a gap round there, but 1mm seems like a good amount. So we're all done. So what we need to do now is just check it's all okay, and is that design rules check, that button. Minimum track width 0.2. Now the standard of these PCB places for the cheapest is, they say, 6mm or 6/1000 of an inch, which is about 0.15, so that leaves us a bit of error. So let's run. Pad too close to pad, and pad too close to pad. I click that. We'll have a look at this. We will take the bottom copper off because it's not on there, and we will zoom in. So right, on that transistor, but that transistor is the standard footprint. So all we can do is pull in the tolerance a bit. So that's not track width or track size or microvia size, it's distance between track to track, or distance between any two bits of copper, but I cannot see where you set that, so I will have to look into that. Okay, so I've been around quite a few forums and what have you, and I believe we have a slight bug on the program. The design rules used to be in a setup menu, and now they've been changed and put in the board setup box. There we go, design rules. But somehow during that move, the pad minimum distance setting has been omitted from there, so we have the default, I guess, which is, so these outlines around the pads are that, so that's 0.3 of a millimeter. Fortunately we can work around it, because if we select the component, go into edit, properties should I say, we have local clearance settings, so we can set it up for that component only to 0.2, and we can see those lines now don't cross over onto the next pad. No, and there goes the dog. So now if we hit that and that, we don't get any problems. Good. However, we've got some unconnected tracks, which I know, which I sort of left on just to check that they would be picked up. So I will get rid of the known unconnected tracks and we'll have another go. Okay, so let's run a rule check again. Now here you can see I've left a bit of track dangling that I should have deleted. So I'm just going to see if it picks that up. No unconnected items, so we're good. It will actually work. Report all errors for tracks. Slower. But not that slow. Alright, test the tracks against fill copper areas. Very slow. Alright. Let's see what that does. Nope. That is a bit annoying that it doesn't spot dangling tracks, but there you go. We're just going to have to spot them by eye. So there she is. I think she's ready to go. So what we need to do now is find out what we need to output for PCBWay to build a board, which I believe is Gerbers, and then do that. Okay, done some final checks, including realising I had the relay on the bottom surface of the board. Would have worked because it's symmetric down the middle, but I like to have things right. So I corrected that and retracked that. So and looked on the PCBWay website. They just want Gerbers and drill files. So let us create some Gerbers. So there we go. It asks what we want for Gerbers. Copper, silk, screen is all we want, and there is a little one, exclude PCB edge layer from other layers. We don't want that on because then the board has no outline, and I have no idea how big the board wants to be. So should we just hit plot? There, done. And here I've created a Gerber folder just for putting them in, and also generate drill files. Yep, I've just taken all the defaults here. So generate drill files, done. And if we go into that little Gerber directory, there they are. And KiCad helpfully provides you with a Gerber Viewer. Which is that. Takes a minute to load up. So let's have a look at them. So they look okay. So shall we order some printed circuit boards? Okay, we're ready to go. So we are just gonna, I think we need to get this quote before we can actually do an order. So length is 100 mil, width is 70 mil, single pieces, one design, 5 pieces, 2 layers, FR4, yeah, whatever the default on that, 1.6, yeah, the default on that, solder mask green, don't care, silk screen white will do, gold fingers no, hassle lead free, that's gonna cost us a bit, but never mind. Via process, tenting vias, yeah, 1 ounce copper. So let us hit calculate. Build time 24 hours. DHL $23. Alright, I did put hassle lead free. Oh, I think before it was charging me extra for lead free. Never mind. Never mind. Save to cart. Is that doing anything? Yep. I think I need to join, so I will do that. Okay, we've joined up. It saved you me typing. And okay, so they want a zip file. So bottom copper, bottom silk we don't want. Front copper, front silk. We'll give them all those. JZip add to zip file. Okay, so we have a zip file called bat charger, which we will now put in there. Submit order now. Okay, under review. That means they're checking they can actually make them. I guess they're not asking me to pay yet. So, let us wait for them to be reviewed. Okay, forgot the solder mask. You can tell it's been a while since I've done this. So, we go back in here. We hit the Gerber buttons. Right, front copper, back copper. Front silk, don't want back silk. Front mask, back mask. And that should do us. And the drill files won't have changed. So if we hit that, that seems to be good. Okay, so we should now also have an F mask and a B mask. We do. So, shopping cart, re-upload file, and let's go into here. Submit order now, and hopefully that will be okay. Okay, we've been approved. Proceed to checkout. See what happens here. Right. Okay, we've got to fill in a lot of stuff. Okay, so was wondering why the... Let me move this so you can see it. The subtotal you see there is $28 instead of $5, and they give you a little Gerber View file here, and here it says the size of my board is 101.8mm by 71.7mm, but I look at the Gerber Viewer that KiCad give you, and we have here a ruler tool. Maybe you can just get that so it's horizontal. Gives me about 99.3mm, and since above 100mm it's suddenly $20 more. That's a bit cheeky really. So, should I go back, shorten the PCB, probably have to fiddle around with a load of stuff, or just go with the extra $20 odd for now and flag it up for future? I think I am going to go with the extra $20 odd for now and hit it. Okay, so there we go, we've got our circuit boards on order, and going to end this video here and reconvene when they arrive. But in the meantime we'll also need to order some parts to put on the circuit board, so in the next video the first thing we will look at is generating a bill of materials and turning that into an order. And then we will get on to building and testing the board. So for now, submit, leave a comment if you've got anything to say about this video, and for now it's goodbye from Tripplikit, home of interesting electronics. Goodbye.